So in this video what we're going to do is identify how to find the equation of a line that is parallel to a given line and that passes through a given or specified point. So in this example it says consider the line given by 3x minus 2y equals 12. Determine the equation of another line that is parallel to the original line but that also passes through the point 4, 3. And the concept is we need to remember that for any line to be parallel to this line, whatever this line looks like, so if this line looks like this, for a line to be parallel to it, they need to have the same steepness or same slope. So step one is to take the line to which we want to be parallel, 3x minus 2y equals 12, and determine its slope. And the way that we're going to do that is to put it into slope-intercept form, the form y equals mx plus b, so we can read off the m and know what the slope is. So essentially what we need to do is solve this for y. So we'll start by subtracting the 3x from both sides, which will give us negative 3x plus a 12 on the right hand side, and then we'll divide both sides. Everything on the left gets divided by 2, everything on the right gets divided by 2, so we get negative 2 divided by negative 2 is 1y, equals negative 3 divided by negative 2 is positive 3 halves of an x, plus 12 divided by negative 2 is negative 6. And so here I have the line in the mx plus b form so that I know the slope is 3 halves. So m equals 3 halves. I want to be parallel to this line, which is the same as this line because I've just done an algebraic manipulation. I've taken the line in standard form and manipulated it into slope-intercept form. So every line that exists that is parallel to this line must have this slope. So now I can go over here and say, find the equation of the parallel line. So to be parallel, we know that the slope of the line needs to be the 3 halves, but we also know that we want our line to contain this point. So and contains the point input 4, output 3. So to find the equation of a line, what we're going to do is say, look, in slope-intercept form, the equation of a line looks like f of x equals mx plus b. And to be parallel to this line over here, I need to have the same slope, so I can just replace the m with 3 halves so that the slopes match. So I get f of x equals 3 halves x plus b. And then to contain this point, we need the line to pass through it. But we know that we have the slope of a line and a point on the line, so we know how to handle this already from a previous video. We just take this point and use it to find b. This says, hey, when the input is 4, the output needs to be 3. And f of x represents the function output, so replace f of x or y with 3, and we'll get 3 equals 3 halves times the input, but the input is 4, so 3 halves of 4 plus b. So 3 is going to equal 2, will go into 4 twice, and 3 times 2 is 6 plus b. And then we'll subtract 6 from both sides to get negative 3 equals the y-intercept of the equation we're interested in. Then we update our equation. Here it had the slope, but we didn't know the y-intercept. Now I know both the slope and the y-intercept, so we know that f of x equals 3 halves of x plus negative 3, or 3 halves of x minus 3, is a line that is parallel to the original line and that passes through the point 4, 3.